Good morning. Today we're continuing our discussion of the Earth's layers. We are addressing the standard S6E5A. Ask questions to compare the contrast the Earth's crust, mantle, inner and outer core, including temperature, density, thickness, and composition. In science, we have two ways of dividing the Earth's layers. We have the physical layers, the lithosphere, the asthenosphere, the mesosphere, the outer core, and the inner core. And we have the compositional layers, which comprise of the crust, the mantle, and the core. Let's start by taking a closer look at the compositional layers. The crust is our uppermost section. It's the section of the Earth that we live on. The mantle is our largest section of the Earth. It comes just under the crust and above the core. The core is the center of the Earth. It is the hottest, the most dense, and is under the most pressure of any layer of the Earth. Let's take a closer look at the crust. The crust is the outermost layer that we live on. It is comprised of the oceanic crust and the continental crust. Its temperature ranges from 0 degrees Celsius to 1,000 degrees Celsius. Its thickness is between 5 kilometers and 100 kilometers. Its composition, or what it's made of, is oxygen, silicon, and aluminum. Those are the main compositions. We also know it is rock, granite, dirt, things like that. But we consider the composition to be primarily composed of oxygen, silicon, and aluminum. There are two types of crust. The first one is oceanic crust. It is thin and dense. Think about all that water compacting the molecules, because it's heavy, compacting the molecules tighter and tighter. So it is very dense. While the continental crust is thicker and less dense. You have the same amount of molecules, possibly, but it's spread into a much larger area. The volume is greater, thus the density is less. Here you can see a nice example of continental crust and oceanic crust. You can see the continental crust ranges between 30 kilometers and 100 kilometers depending on the lay of the land, while the oceanic crust is generally around 5 kilometers. It's very thin, densely packed. So oceanic crust, again, is much denser than continental crust. Again, think about the same amount of molecules packed into a much smaller space. As we travel down through the Earth, the next compositional layer we meet is the mantle. It is below the crust, but above the core. Its temperature ranges from 1,000 degrees Celsius to about 3,700 degrees Celsius. Much hotter than the crust, but not as hot as the core. Its thickness, being the thickest compositional layer, is about 2,900 kilometers. It is made of solid and molten rock. Most of the Earth's mass is found in the mantle. Remember, it's solid and molten rock. It is not liquid, but it is a melted, ooey gooey rock. Finally, as we travel through the Earth, we reach the core. It is the Earth's center. Its temperature ranges between 3,700 degrees Celsius and 7,000 degrees Celsius. It is hotter than the sun. Its thickness combined is about 3,500 kilometers. But remember, we do have a division of the inner core and the outer core. Its composition is mostly iron with some nickel. So both layers are made mostly of iron and nickel. And again, we usually divide it into two layers, the inner core and the outer core, because physically they are very different. Let's take a look at the physical layers. There's a silly sentence to help you remember the physical layers of the Earth. Let for lithosphere, Autry for asthenosphere, Mil for mesosphere, outer core, A for chocolate, inner core, ice cream. So if you remember let Autry Mil offer chocolate ice cream, you can remember the order of the physical layers: lithosphere, asthenosphere, mesosphere, outer core, inner core. These are the physical layers of the Earth. Let's start at the top physical layer, the lithosphere. We live on the lithosphere. It is that crunchy layer of Earth on the top. Its location is the crust and the uppermost part of the mantle. Its thickness is about 15 to 300 kilometers, and the lithosphere is divided into tectonic plates. We'll learn more about those tectonic plates next week. As we travel down, we will enter the asthenosphere next. It's the middle of the mantle. It's soft and can bend like plastic. Okay, think about silly putty or Jello. The lithosphere floats on this layer. So you've got the asthenosphere, and you've got the lithosphere kind of floating on top of that all the time, moving, plastic-like asthenosphere. Its thickness is about 250 kilometers. As we continue through our journey down to the center of the Earth, we come to the mesosphere next. It is located in the lower part of the mantle, and it's about 2,550 kilometers thick. It's the thickest layer of the mantle. We have now reached our core. The outer core is made of liquid iron and some nickel. Again, this is liquid iron. The outer core is the only layer of the Earth that is liquid. I know we said the asthenosphere is kind of ooey gooey, but it's not liquid. The outer core, again, is the only liquid layer of the Earth, and it's made up of iron and nickel. It's about 2,300 kilometers thick. And we have finally reached the inner core on our journey. It is made of solid iron and some nickel. It's solid because of the increased pressure, temperature, and density. Think about the center of the Earth has all the pressure from the rest of the Earth pushing in against it. It's about 1,200 kilometers thick. So in review, the compositional layers are the crust, the mantle, and the core being divided into the outer core and the inner core. And the physical layers comprise of the lithosphere, the asthenosphere, the mesosphere, and then the outer core and inner core. It's really important to remember what happens as you move toward the center of the Earth. The density increases, you've got more and more pressure, and it gets hotter and hotter. All three things increase. As you're moving in, you're packing more molecules into a small space. That is why density increases. As you move in, you've got more and more layers creating pressure on the inside layers. That's why pressure increases. And as you go farther and further into the Earth, there's less and less places for the heat to escape. So it gets hotter and hotter. So the deeper we go, all three increase, which makes the core the highest density, the highest pressure, and the highest temperature. And the crust, the lowest density, the lowest pressure, and the lowest temperature.